All right, so we're doing technical diagrams. This is chapter 1 in your book. So first of all, what is a blueprint? We tend to toss that term around a lot, yes? So what exactly is a blueprint? I'm asking y'all, what do y'all consider the definition of a blueprint? A structure, an outline, what else? Not so much on graphs. Kind of like they say genetics and DNA is the blueprint for you. So in that context, what it means is basically it's almost like a map as to how to build something or how something is set up. Does that make sense? Oh, come on. There it goes. So this right here, I don't know who particularly picked this one, but anyway, so this is a blueprint of the Starship Enterprise. And what it's showing you is, it's calling it the top view, so that it's showing you all the different things on it and where it goes. Does that make sense? Like I said, blueprints are kind of like a map telling you how to build something or make something in a way that is cohesive. Okay? So here's another question for you. What is a symbol? Because when we do blueprints, we do not write everything out. We don't want everything spelled out because that might as well have just built it ourselves at that point, right? So what is a symbol and why would we use that instead of, telling somebody exactly what this is, where to find it, how to find it, and everything else? So what is a symbol? We use the word symbol a lot, but what is kind of like the meaning of it to y'all? What something stands for. It's a representation, right? Kind of like the peace sign. It's not actually the peace sign. It is meant to be a symbol that says, oh, we use this to symbolize we want peace, right? Before the Nazis got a hold of it, the symbol that's the swastika was used in thousands of pieces of art all over everything. They corrupted that particular symbol. In fact, the history on that one's quite interesting, but I digress. Symbols are meant to represent something, like the flag, the American flag. What does it represent? It represents our country. But it is a symbol, it is not our country. So, it's an object that represents, stands for, or suggests an idea, visual image, belief, action, or material entity. Another one you can say is a symbol is the cross, right? That's a religious symbol. You can go on and on because most of what we do in everyday life is nothing but a symbol. Even our alphabet is nothing but a bunch of symbols. And that's every alphabet that's ever been created. Numbers, letters, all of that come together to make 1,000,001 symbols. Okay? But we have to find ways to use symbols in ways that are cohesive. In the case of the alphabet, we use those symbols to form words that we can then pass information from one person to another. Right? Because the very first thing we learn in kindergarten, A makes the ah sound, so on and so forth. I'm not getting into all that one. So it is used to represent, stand for, or suggest ideas, visual images, beliefs, actions, or material entity. Material entity. Let's see if y'all kind of follow along on this particular one. Because what does this particular one, what does that represent? I know it's a crappy drawing, I'm sorry. That's Amazon. We've now associated Amazon with the little smirky smirk, right? And if you've ever ordered off of Amazon, you know that the package that is from them carries that symbol. So that would be of a material entity. Traffic symbols. I don't know how recently any of y'all took your traffic test, but there are quite a few symbols out there that we have to always know of, right? And most of them visually, they have created ways for us to sit there and go, oh, this means that. This one right here generally means what? The one at the very top, the red with the white line through it. Do not enter. How do we know that? Because we constantly see that symbol paired with the letters do not enter or wrong way. So these are used frequently to try and tell us information we need to know. Roadmap symbols. When's the last time any of y'all actually opened a map? There wasn't a Google map. Yeah, that's exactly what I mean, is that almost none of us use maps anymore, but if you ever do, this is what you should see. That, or if you ever go to the zoo and start trying to look at a zoo map. Or you also have maps in the mall. You know, every place has its own maps just so they can sit there and say, you are here. Here's where you want to be. How do I get from here to there? Go that way. Or you can go around the whole mall and try and find what you're looking for. So this is just a bunch of map toolkits and legends. So, and we'll talk about that in a minute. So things like the triangle. This is a specific symbol. So in math, we use it to represent a change or difference. You have the Greek letter delta, which that's a reference to their alphabet. But these days, what do you see the little triangle delta used for? You usually see it attached to either a sorority or a fraternity, right? You have the symbol for an amplifier. That is a component for digital circuits. You have the symbol for a diode. It uses that. What is a diode, by the way? Let's see if anybody remembers. What is a diode? We use LEDs, which those are light emitting diodes, but all diodes are a one-way bridge. You can go one way, you cannot reverse it. Okay? You have a connection point or common, not to be confused with earth ground. That is one thing that will drive me absolutely insane, is people always use earth ground when they should be using common. Earth ground means you've got somewhere, some way along your circuit, a connection to earth. If you go look around your house, you should have a piece of metal sticking right up next to your house, probably next to your electrical panel, or the feed for your electricity into your house. You all know what I'm talking about. That is called a grounding rod. That takes excessive energy from the power lines, drains it to ground. Common points are what everything in your house connects to, because it all connects back to the panel. Does that make sense? Like I said, that's one that drives me the most nuts because it is the most wrongly used. So, because there is a difference between the two. If you are grounded, your circuit is about 1,000 times safer than if you're ungrounded. So then we have what's called a buffer, and we have inverters. You should notice that half of these are from electricity and electronics. So, but we like to use the triangle. Why? Because a triangle points the way, right? It's a good thing about a triangle. It can point the direction you need to go. So, has anybody ever heard the term schematic? Everybody who's ever been in intro or DC should all nod your heads. At least if you've been in that class with me. Because what is a schematic? It's a diagram, huh? It's not just strictly for electrical. Schematics are the most simplified version of a diagram. Okay? A blueprint is just any kind of diagram. Schematics are very specific. Here's the very base of all this and how it's supposed to look. It's the best way I can say it. And this is the simplest way to say it, is that it's a line drawing made for technical or scientific purpose utilizing symbols. That's a great test question, by the way. Y'all might want to highlight that in your notes, because that's a frequent flyer on test questions. So it is a line drawing made for technical or scientific purpose utilizing symbols. Okay. So like I said, it is the simplest form of a drawing. Now, that's not to say that it doesn't end up looking like spaghetti got spilled all over your paper and just straightened into lines. But that is the most simple rendition of a blueprint, of a diagram. Okay? Does that make sense? So you might want to make sure you highlight that in your book or your notes whenever you get the opportunity. Because that particular one tends to pop up a lot. So schematics are like speaking a language using symbols. All language is made up of symbols. You are going to be learning a few different parts of other languages in this case. So technically, this is a language in and of itself on its own. Does that make sense? Because think about it. If you're given, how many different types of drawings are there? Let's say you're building a house. Okay? So first of all, you have to have your concrete drawing. Why? Because you need to know what kind of rebar you need to put in, what needs to go under the concrete, where it needs to be poured, what thickness, and how much reinforcement. You have to have a blueprint strictly for that so everything goes up smooth, right? If I'm building a high-rise, that's all made of concrete. If I don't know my structural limits of that concrete and have a blueprint on where and how I'm supposed to put everything, my point loads could be off and my whole building will crumble. If it's just your house, you could end up with a lot of leaks and seepage from the ground, which, if you don't know what that does, you're talking molded carpet pads, you're talking molded carpet. If you're talking tile, you're talking about the fact that grout really won't set too well, tiles crack, everything else. All of this goes into how am I going to just pour concrete. After we pour the concrete, it sets, it cures, then we go to framing. Right? And here we're talking another language. Now, what do I mean by that? Well, have you all ever seen a framing job? Anybody ever watch DIY Network and things like that? You have to have blueprints. How far apart are my walls going to be set? Where are my doorways? Where are my windowsills? That's another language that you have to talk. Now think about a contractor, the main person that's overlooking all this and verifying the work. That's two languages he has to learn, right? Because he's got to be able to communicate with my concrete guys and my lumber guys. Then we go to electrical. That's another language. Why? Because we as electrical people know how to talk the talk. We know what we mean when we say, well, I got to run this through this wall. It's got to be this high off the ground. I'm going to put this in front of it so my wire doesn't get hit by a nail or something. We know how to talk that talk. Here's how we terminate. Here's how we splice. Here's how we do this, that, and another. This is the single pole double throw switch that we're going to install. Then you have drywall, which that tends to go with framing. And then you start putting in all the electronic appliances and things like that. You got to talk to the carpet guys. You've got to talk to the flooring and other experts. Everybody has their own language. The plumbers, that's another set that have to have their own language, right? Because is plumbing electrical? No, it's not framing either. So they have to talk to the framers to make sure that they have the right holes cut for the plumbing. So symbols are a language. All schematics are languages. And it's just, how do I turn my brain into reading this language? Does that make sense? So if you're a contractor, you have to be multilingual. Most of us in trade, we don't have to know all this. What do we have to know? Well, at the very least, we have to know our own language, right? I'm not talking English, I'm talking if you are in electronics. You have to be able to speak the electronic language, know what symbols mean what. If I'm in electrical, I have to know the electrical language. But that doesn't mean I have to know plumbing and drywall and framing and everybody else. Symbols are connected using lines to represent a system. We're learning how to read the language because we've had to come up with our own language from all this. So the word schematic comes from the word schema, which in Greek means to form and in Latin means to figure. Not much difference between Greek and Latin on that one. Modern definition is a line drawing made for technical or scientific purpose. There's probably some other examples of that word throughout history. So the best definition of schematics has 5 parts. It's a line drawing. A line drawing is the most simplified form of a drawing. Okay? Because you're not doing complicated, showing how everything looks in physical time. You're just putting in a symbol. And symbols are a lot simpler to put down than, say, actually trying to draw something if you're not an artist. It's made for a scientific or technical purpose. So scientific purpose, what do we mean by that? What do y'all think? Who took chemistry? Right? When you're trying to put different chemicals together, they're not something in front of you that's telling you how it's supposed to react? Does that make sense? As for technical purposes, I think we all know what that is, right? We are in a technical trade. It shows how a system works from beginning to end, or at least for that little section of what you're doing. Symbols used instead of pictures. Why? Because we want to take up as little space because we need as much on here as we can. The bigger you put something on a piece of paper, the more space it takes up. The more space it takes up, the more paper you're going to have to use, and the bigger the blueprint. Okay? The symbols are connected to show how the system operates. Okay? So reduce complicated systems to manageable drawings that can be understood. Why? Because I don't know about y'all, but the engineers tend to talk a lot about a lot, right? And the simplest we can make that, the better, right? You understand what I'm saying? The simpler we can make it, the better off we'll be. The more complicated you make anything, the easier it is to break it. The simpler it is, the better off you are. Okay? So this is a simple electronic schematic. The simplest one, you have your source, path, and load. Here, you have your your signal coming in, you have some components coming through, and then you have your horn on the outside. That's a very simple siren schematic. All right, so this is a printed circuit board. Now, this one's actually fairly easy to trace simply because you can follow the lines and all that. And this is great, don't get me wrong. This right here tells me how it's actually hooked up, which terminals are being used and which aren't. This is great and all because it can show me a few things, shows me how it's actually put together. It tells me a little bit about how it works. This gives me something a little more in depth. All right, this one is a solid state Tesla coil. That is not the best way I can see that. I don't know why. The background is trying to stand out against that. If you're going to do a black background on anything, make everything else white, high contrast. Red contrast does not work very well, does it? All right, so you got a high frequency generator. You've got something to measure duty cycles, low frequency interrupter. That's about all I can really tell from some of this. Looking at them on here. This is a galvanizing line from US Steel. I'll go ahead and tell you this, guys, because in the book, I think it calls this a line diagram or it calls it something else. I will go ahead and tell you now. Those of you that have not taken something like PLCs or motor controls, this is a what for those of you that have taken PLCs or motor controls? Because this is something Rich would have beaten into you. It is a ladder diagram, right? This is ladder logic. Why they call it ladder is because you have the two main sets, the two main sides, and then everything in between is supposed to set it up looking like a ladder. If you ever take PLCs or motors, Rich is very, very happy to tell you all about this. So this is a ladder diagram. But what this particular diagram shows you is what? It shows you how everything, it's not so much about how it's wired as how it's put together and how it works and interacts with itself, right? We'll talk some more about those whenever we get a little bit closer to the end of the class. All right, this is a building diagram. And again, you have to know the language you're talking. This particular one, if I'm right, is the electrical schematic. And how do I know that? Well, because these are these up here, the lights. Okay? And you've got how everything is wired together. Okay. So let me put it this way. If I gave that to somebody who's doing framing, are they going to know what they're looking at? No. If I gave that to a plumber, are they going to know what they're looking at? They don't, because they don't speak the what? They don't know the language. It's the symbols language. Okay? Going back to the Starship Enterprise. And if you're a model maker, this makes a lot of sense, right? Does anybody do model making or know somebody that does? Probably not. Okay. Model makers are very, very precise. They want everything to match up perfectly with what in this case, what the original TV show would have been, right? Because if you're doing a Starship Enterprise, let's just say, I'll go ahead and say it. I used to be a Star Wars geek, not so much a Star Trek geek, but there are Star Trek geeks that would get very upset if that is not correct. Okay? So if you're model making, you want everything precisely where it's supposed to be, exactly when it's supposed to be there. This is so how, for those of us that are doing electricity and electronics, how would I know that this is something like a electricity or electronics diagram? So that's exactly what this is. I start looking for anything I can pick up that I know what it is. So I know that that's a diode right there. Those are transistors. Okay, you have, I think, some amplifiers in here. You've got chips, IC chips in it. So what you have to start looking, when you're reading any schematic, start looking for familiar symbols. That's how you can tell one schematic from another. Okay? Another wiring diagram. Reason I know it's a wiring diagram is because you have motors on here. You have a junction box. You have the transformer right here. These are what a transformer looks like. What does a transformer do? Anybody remember that one? Yes. It takes voltage from something like, I think, 2,000 volts on a pole down to 120 in your house. And in your house, do you want 120 in everything? No. You put that onto a computer, you're going to fry it. What you do instead is you have a transformer for your computer. This nifty little thing. Not only does it transform it from 120 to 12 or 24 volts, this also turns it from AC to DC. There's an AC to DC filter. So like I said, you start looking for familiarity. All right, this is a power amplifier kit. Okay, you can tell again that it's electronics because what are these the symbol for? Those are resistors. One of the most common electronic components. This one is an HVAC control module. So these are just all sorts of different schematics. This particular one is actually hydraulics and pneumatics. This particular one is pneumatics. Yes, it's pneumatics. So you have compressors, you have valves, you have an accumulator, you have all sorts of fun toys on this one. If you've taken on hydraulics and pneumatics, that is a really interesting way to do a schematic. All right, so let's look at this real quick. So again, we were talking about the fact that a schematic is a basic line drawing, as simplified as can be. Which one of these takes up more space on a paper? This one on top, right? It shows me exactly how everything is wired, and that's great. But that's going to take up a lot of paper, and it's going to take me a while to track down every component I need, especially if it starts looking like spaghetti monster. Got a hold of it. This is the most simplified version of that instead. Okay. All right, so this particular one is hydraulics. I know it's hydraulics because I have a tank. Hydraulics, think about your car. How many of you have ever worked on your car, on your brakes? Then what do you have to do periodically? You have to drain the brakes. You have to refill the reservoir. That's the exact same picture. Piping diagrams. So we'll be looking at a few of these. Excuse me. We'll go into depth on piping diagrams when we get there. All right, this particular one's a combination drawing. Why would we need a combination drawing? Well, because sometimes you not only need to know what components are there, but maybe you're looking for a specific piece of the puzzle. In this case, they've got it heading to, I believe that's a generator that they're trying to show you, or just steam generator is what they're saying it is. Kind of looks like a hot water tank, but I think it's generating steam instead of hot water. But if you notice, this thing has 3 places where it's got pipes coming in. It's got here, it's got 4. So the reason you would use a combination drawing like that is if you have something complex like that. Okay? You can still do that as a flat line drawing, but it could get a little more difficult from that. I think somebody put the wrong picture on this one. We use arrows generally to show the direction of flow in any circuit. That's what arrows are great for. You are going this way. This is going this way. How do I know which way it's going? You look for the arrow. And then we have supplementary diagrams. This is these are alternative views of diagrams, and we'll talk a lot more about those as we go. Any questions on chapter 1, guys? I'll let y'all take a break right after this. Anybody? All right.